It's just line graphs, so. What else? And we are going to graph, we're going to graph lines in 3 different ways. I'm going to show you 3 techniques. You should have seen all of these before. But we are going to use 3 different kind of approaches to graph lines. So this first one, what we're going to do is we're going to make a table, which is kind of a guess and check situation. Oof. So what I'm going to do here is I'm going to pick values to go in one of these places. If you see numbers up here, I do recommend trying them out certain places. Like, I wonder what happens if x is 3.
9. Y is 9.
Is y 9? Easy trap. Because what we have is now 3 plus 3 times equals 0. Subtract 3 from both sides, we get that 3y is negative 3. What's y equal? 3 times what is negative 3? Negative 1. What happens if y is 3? So let's plug that in. X plus 3 times, whoa, this one's going to be big, 3. That one's not even going to fit on my graph, but that's okay, we can see it. If x plus 3 times 3 is 9 equals 0, what does x equal? X plus 9 is 0. Negative 9. Well, that one's not on my graph. That doesn't help. So let's make y smaller. Let's make y 1. X plus 3 times 1 equals 0. X plus 3 equals 0. So what is x going to be? Negative 3. So this works. Totally functional. Absolutely thing you can do. It's not very fast, though. We're just guessing. We are blind guessing. Okay, we have wound up with at least 2 points that'll show up on our grid. It takes at least 2 points to make a line. More is great. 2 is the minimum. Where we're going to have the points 3, negative 1, so we've got 1 right here. Negative 9, 3 is way off my grid. It's off this way. And then we have negative 3, 1. So that gives me something. Something's better than nothing. Something's better than nothing. So what we're going to do is we can connect those up. I have 2 points for a line. That's all it takes. More is better, but 2 is enough. And you're going to use a ruler or a straight edge or the edge of your notebook or the edge of your ID or the edge of the box that holds the scissors. I don't care what you're going to do. You're going to use a straight edge of some sort. I have to freehand it because my iPad is a grumpy Gus when it comes to anything touching the screen other than my finger. We're going to do it at least a little better than that. There we go. If you want a ruler, I have bunches. see, I don't think that I have any short ones still. But like, I have lots. Toss one on each set. With the yellow one. I'll toss a few out if you want to. Let people sit there later. But use a ruler when you are drawing lines. Lines need to be straight. I know that's so pretty up there. There you go, dear. So you can absolutely make tables. Totally fine. Just slow. Okay? It works. It does the job. But it's really, really slow and you're guessing. So we're going to do a couple more ways that are a little bit less guessish. Yes. So this is our second one. And what we're going to do is we're going to graph with our x and y intercepts. Remember, that's when it crosses our axes. So the one thing I know about my x-intercept, I know it's on this line right here, which means I know for sure my y value is what? 0. So if I want to know my x-intercept, we can substitute in 0. So 3x minus 2 times 0 equals negative 12. Okay, that minus sign is actually supposed to be there. There we go. That is a weird, okay, I'm gonna fix that. That's a mess. That's equals negative and it just looked weird. There we go. The easy way to do this is, well, 2 times 0 is 0. So what we really get is 3x is negative 12. It's called the cover-up method. So it's substituting in 0, but it makes this term disappear. 3x equals negative 12. What does x equal? X is negative 4. So our x-intercept is at negative 4. That tells me this point right here. To get the y-intercept, we do the same thing the other direction. We say, all right, what happens when x is 0? This term's going to disappear. 3 times 0 is 0, so we have minus 2y is minus 12. If it helps you to write that whole piece out instead of just covering it with your finger, that's fine. If you could cover up and do it, that's fine. You can always write fewer steps than me. I will just write them all out. So you get minus 2y equals minus 12. So what does y equal? 6. Positive 6. This is our y-intercept. So it's way up here. Let's see. Oh, I found a tool that'll let me do lines a little bit. So your line should look like that. This table is so squeaky. So x and y intercepts are faster, and they will get us onto our graph a little easier. So when it's in our standard form, which one am I pointing at? where it looks like this, where my x's and y's are on the same side of the equal sign, sometimes our intercepts are the easier way to go. You can always solve it to get y by itself, get y on one side, everybody else on the other, and graph things in slope-intercept form. I wonder what's next. Okay, so this is definitely one option, graphing with your x and y intercepts. Our last way that we have graphed that should hopefully be familiar, since probably the one we are most familiar with, is our slope-intercept form. Y equals mx plus b. And it's all about matching things up. Give me a second to write that because I know a bunch of people are writing. So find our slope, find our b, find our m, find our b. What is our slope from our equation? What's our slope on this one? 3 halves. 3 over 2. What's our b? -4. This is our y-intercept. It straight up tells us. So we can plot the point, -4, on our y-axis. 1, 2, 3, 4, right there. And we use the slope to find our next point. How do we do that? What do we use to remember how slope goes? Rise over run. So I'm going to go 3 up, 2 to the right. So I'm going to go from this green dot, 1, 2, 3 up, 1, 2 over, and we get a dot right here. I can do that again, up 1, 2, 3, over 1, 2. I could do that again. 1, 2, 3, 1, 2. The more dots you have, the easier it is to get a straight line. So I always fill mine in as many as I can. And we connect them up. It should look something like that. For those at least vaguely familiar, we spent a long time on them in Algebra 1. They should hopefully come back out of the recesses of the storage in the brain. I know sometimes we put them on a shelf, they get dusty. It's been there a minute. It's been a hot minute since we graphed. So that's what we're working on today, is graphing lines. It was just a really quick refresh on how to graph a line. We will work more with lines after the quiz, but we, could see a graph or two on the quiz. I am not going to give you a separate homework for graphing lines right now because I have a review for you for the quiz. Tomorrow, we will work through absolutely any question on here y'all want to go through, which means y'all should try to go through some stuff so you know what questions you want to do. Okay. So I'm going to give you this review. It is 3 pages, so it feels like a packet, but it's really just like front by front. Okay. things we've been through so far is here. Help us get ready for that quiz. That is Friday. So you have today to work on this. Tomorrow we will work through some questions together, or you guys can work independently. I don't really care. If you finish this and you want more practice questions, there's more practice questions on Alex. There is a optional assignment called Unit 1 Quiz Review. I think. Or Quiz 1A Review. Module 1 Review. I don't know what it's called. I don't remember. I've slept since then. Okay, but there's lots of pieces in here. If you want to practice your graphing right off the bat, I think it's on the second page. Number 8 has graphing. Okay, so if you want to go refresh your graphing skills again, you've just graphed 3, but number 8 has graphing. So this kind of touches on all the pieces we covered. Okay, so do this, work on this, ask questions. I'm here to help. You guys can work with each other. You can work on with your music on. I don't care. But work on it. Ask questions. Tomorrow we will work through together on the board any question you want. Yes, ma'am. Yes, ma'am. Okay, I'm going to turn off.